Let's look at a different method of solving quadratic equations if you can't happen to factor. So this method is called completing the square, and the whole idea is being able to solve a quadratic equation or solving a quadratic equation by doing what's called getting things written in terms of a binomial square or a squared binomial. And the reason we want to do that is so that we can take square roots of things. So here's our first example. X squared minus 100 equals 0. Now, one thing you can do is factor this by decomposition. And if you did that, you would end up with this. And from that, you would then determine that x is equal to plus or minus 10. And you would be done. But this would be one way of solving it. Another way of doing it is by looking at this and recognizing that this is a difference of squares. And based on your difference of squares, well, we would get the same thing. You would factor it by difference of squares, and you would get the same thing. And then you could conclude that, hey, x is equal to plus or minus 10. Now, a third way we could actually do this is to basically have a binomial square, or, not in this case, it won't be necessarily a binomial, but using what's called a square root method. And that would be to rearrange this equation into x is equal to positive 100. And then you can actually take the square root of both sides. Okay? And the square root of x squared, right? Square root of something squared, well, you're just left with x. Now, when you take the square root of 100, remember that you've actually got two answers, the plus and the minus square root of 10. And lo and behold, we've got three different methods to solve the same question. One is by factoring either through decomposition or product sum, or however you want to classify that. The other method is recognizing this as a difference of squares, and there you go. And this third method is taking square roots. So why is this useful? Well, let's look at something like this. Same sort of deal, but at least we have a trinomial now. If we factored this, we would end up with, if we factored this, we would end up with an x plus 1 times an x plus 1 is equal to 0, and then we could conclude that x is equal to negative 1. Okay, that's one way to do it. The other way to do it is to rewrite this as x plus 1. Now this is sort of a longer way. I mean, once you get to here, you know it's kind of redundant to do it this long way. But if you wanted to, you could write this as x plus 1. X plus 1 times x plus 1 is x plus 1 all squared, and that is equal to 0. Now, we could take the square root of both sides, and we end up with x plus 1 is equal to, now the square root of 0 is just 0, therefore x is equal to negative 1. And we end up getting the same answer, but we used a different method called this square root method. Now, why is this topic called completing the square? Well, let's look at an example where the question itself, or the trinomial itself, actually isn't factorable at all. 2x, let's go with, minus 5 is equal to 0. Okay? Now in this case, when you do your product and sum, your product is minus 5, and your sum is 2. This isn't factorable by all the ways that we know so far. Right? It's not a difference of squares. Product and sum doesn't give us anything useful. And so what I'm going to do is just like what I did up here, where I could factor this into something squared, or all the way down here, I could take this thing and factor it into a binomial square, or in this case, I could factor it into, well, not really a binomial square, but I could factor it into something squared. I'm going to do the same thing here, except the problem is x squared plus 2x. That minus 5 doesn't allow me to actually factor this into a binomial square. So I'm going to ask myself, well, what actually does allow me to factor this into a binomial square? Okay. So what I'm going to do is try and come up with a solution that where if I were to cut and paste or put a number in there that lets me factor this into a binomial square, let me see if that actually helps me. So I'm going to do this in 2 steps here. So x squared plus 2x. Now I've got a minus 5 on the left side of the equation here. I'm going to rearrange this so I get a plus 5. So I'm going to write this as a plus 5 on this side. However, remember that if I'm going to add something here to make this whole thing nice and factorable, whatever I do to one side of an equation, I have to do to the other. So I'm going to add something to both sides here. Now, what is that something? Well, I'll may as well just tell you. To find that something that goes here, what you need to do is identify the b value in the ax squared plus bx plus c format of a quadratic equation. And identify the b value. In this case, it's 2. Then you need to cut that in half. And in this case, it's 1. So half of 2 is 1. And then you need to square it. And you'll see in a second why I'm doing this. You need to square it. So 1 squared is 1. But you're going to leave it written like this rather than actually just simplifying it to 1. So plus 1 squared, but whatever I do to one side, I have to do to the other. 1 squared. Okay? So how does this actually help me? Well, x squared plus 2x plus 1 squared is equal to 5 plus 1 is 6. Okay, why did I happen to choose or pick 1? Well, this factors into x plus 1 times x plus 1. Or in other words, x plus 1 all squared. Voila. The whole purpose of trying to actually figure out what number would go there nicely is so that I could actually arrive at turning this into a binomial square. Now, why do I do that? Well, the original question is this: x squared plus 2x minus 5 equals 0. And I've determined already that it's not factorable. So I need to figure out a new way to be able to isolate x and get it by itself so that I could solve for it. Factoring won't help me here, so I've got this new technique called completing the square. Or in other words, find something that you have to put in here so that this thing is completed to give me a binomial square. Or complete, right? Put something in there so that you can complete the square. Now I can take the square root of both sides. Okay, but remember that when you take the square root of a number, you end up with the plus and the minus version of that number. And so x is going to equal plus or minus square root of 6 minus 1. And I'm done. So now, without factoring, I've actually figured out what my two solutions are. Okay, one of them is going to be, maybe I'll split them up. One of them is going to be positive square root of 6 minus 1. The other one is going to be negative square root of 6 minus 1. And those are my two answers. So this technique is called completing the square, and this is what you need to be able to do. You have to be able to identify the b value, then take half of it, and then square it. The reason we do that is that this number that you end up with is going to allow you to be able to factor this into a binomial square. If this is, let's say, 2 squared or 7 squared, it's not going to factor the way I want it to. So what I'm doing is searching for the number that will allow me to factor it the way I want it to. Alright, anyway, so that's how you complete the square. Sounds good? I think so. Alright, goodbye.